Good morning. Today we're going to be talking about stable and unstable systems, and also how we as control engineers can transform an unstable system into a stable system. Let's describe first a very simple control system, a very simple dynamic system. We have something that looks like this, and then we have a ball here that is certainly a very stable system. I can put that ball here, and if I let go of that ball, the ball would go into that condition, in that location. So this is a stable control system, a stable dynamic system. Now let's look at a different system. Let's look at a system that kind of looks like this. And now I am going to put the ball right over here. Obviously that is an unstable system, because if I let go of that ball would either go this way or this way. So okay. Two dynamic system, one stable, the other one unstable. Now let's look at something else that is a little bit more complicated. By the way, this particular system is called an inverted pendulum. It is an inverted pendulum because the pivot point is at the bottom rather than at the top. Now notice that if I let go, it falls. So again, I am dealing with something that is unstable. However, if I use my limited athletic skills, look what I can do. I can make it stable. So let's represent that system using the block diagram representation that we've been talking about. If we go back to the block diagram representation, this is what we have. We have some controller, then we have some kind of a driver, and then we have the plant. And this is what is unstable. But we are going to use some feedback, some kind of a sensor. Go back to our feedback block diagram that we use over and over again. And now, even though this plant is unstable, by the right type of feedback, we can make it stable. We're going to come up with a controller that makes the system work in a stable manner. That is the job of a controls engineer, to take a plant that is unstable, take a plant that is sluggish, and by proper feedback, make the whole thing work in a much better way. Now, before we can do that, we need to obtain mathematical representations for those plants. And that is what we will be discussing next.